Hey guys, back with part two of this first thermodynamics problem. This part C is looking at an entropy change. The equation you're going to need for this, delta G equals delta H minus T delta S. You're determining the free energy change here. That's your delta G. You're told that. So we're going to substitute into this equation. The delta H was given to us in the last problem we used. Negative 23.44 kilojoules, right? Minus T delta S. So minus T, we're at 298 Kelvin, it tells us right here. And our delta S is 78 joules per Kelvin. Negative 78 joules per Kelvin. This is in kilojoules, and this is in joules. Now, we're going to have to either turn this guy into kilojoules or we're going to have to turn this guy into joules. Either way, we're going to have to do our problem. So if I wrote this out, this would be negative 23,400 kilojoules, or joules rather, minus 298 times negative 78. So this is going to be, obviously, if we're subtracting something that's going to be a negative, this is going to become less negative. So if we multiply this out, negative 78 times the 298, that's going to leave us with a total of negative 196 joules. Or that's going to give us negative 0.196 kilojoules. That's going to be our delta G. Important thing is that it comes out to be negative, right? Again, this is, what do we have, 3 sig figs with our temperature, so I would again leave an answer with 3 significant figures rather than rounding that off, okay? We're asked to follow that up in this part D, right? It says respond to questions based on our calculations that we just did. Okay, so let's look at the first part. It says, would the forward reaction proceed spontaneously? Well, let's go to letter I here. Yeah, it's going to be spontaneous. Definitely going to be spontaneous, and it's going to be spontaneous because your delta G is negative. And that's what happens if you get a negative value for delta G. Now, if you calculated a positive delta G, then you're going to have to say it's going to be non-spontaneous. It should be consistent with what you said back in part C. Part 2 says if the temperature was increased, would the value of delta G increase, decrease, or stay the same? So let's think about our equation over here. We had a negative value for delta S. If the temperature is going to increase, that means this whole part over here, right, we're subtracting a negative, which means that's going to be positive, which means your delta G is going to increase. It's going to become more positive. So delta G is going to go up, and you want a justification that goes along with this equation. You have to state something about the T delta S part of that equation to answer this question. Part 3, the equilibrium constant. Is the value of the equilibrium constant K at 298 larger, smaller, or equal to 1? Well, that takes us back to this equation. Delta G is equal to negative RT ln K. This is going to be on your equation sheet. This gives us the relationship between delta G and K. And so if you look at how this equation is written, this is a negative here, right? So if you take this part of the expression, this is the only part that could be negative, right? Temperature can't be negative. That's always going to be positive because it's in Kelvin. Your R is always going to be positive, right? It's the K. If you have a number, a K that is less than 1, that's going to give you a negative for ln K, which is going to give you a positive value for delta G. If you have a K that is larger than 1, that's going to give you a positive number here, which is going to give you a negative delta G. If your ln K is 1, that's going to give you a I'm sorry, if your K is 1, that's going to give you 0 here, which means you're going to be at equilibrium. Okay, so in this case, since we are spontaneous, negative delta G means that K is greater than 1. So if you think about that, you know, you want to turn this expression, a big K value means that the products are favored. When the products are favored, that's going to be a negative delta G, right? If you had a positive value of delta G, your K, as I said, is going to be less than 1. And if your delta G is 0, right? If our delta G is 0, what's that telling us? It says K that our K is 1. Neither one is going to be favored in this case, either back or forth. Okay? And I'll finish up with this last part real quick. This is not really hard. These should be 2 probably easy points. I would say all of these were worth 2 points, except for D should be 3 points, you know, 1 for each of them, provided you have the correct justification. In this case, it's asking us about carbon. What's happening to carbon? Is it being oxidized or reduced? And you want some kind of a justification. Well, remember our rules. Oxygen is going to be a 2 minus, right? We know that when it's in compounds, unless it was with fluorine. And these have to add up to be 0, which means your carbon is going to have to be a 2 plus. The carbon on this side, we've got 2 oxygens, right? So that's going to be 4 minus, right, total. These have to add up to be 0, so the carbon's going to be 4 plus. So carbon's going from a 2 plus to a 4 plus. It must be losing, right? There's going to be a loss of 2 electrons, right? Oxidation is loss, reduction is gain. Remember your oil rig. So this is going to be oxidized. So in order to get this question, you need to say it's oxidized, and you need to say something about how it's losing electrons because it's going from a +2 to a +4. F says determine the number of moles of electrons being exchanged in the reaction. Well, we've identified that this is a change of 2. I just said we're going from 2 plus to a 4 plus. Well, that's great. We're losing 2 electrons, but let's come back to the balanced equation. There's 3 COs, right? And 3 CO2s, which means 3 times 2, that's going to be 6 electrons being exchanged from one side to another. 6 moles of electrons. We could also look at it in terms of the iron. The iron here is a 3 plus, and there's 2 of them, so that's 6 plus. On the other side, our iron is 0. So if we were looking at the iron part of this, we're going from 6 plus to 0. That's going to be a change of 6 moles of electrons. So you want some kind of a justification for that. It doesn't ask you to justify this, but if it says what's the number, you need to be able to state it and show some kind of equation that goes with it. So it's a pretty solid question. If it takes you, more than 20 minutes, this is something that you should probably go back and focus a little bit more on. I'm going to repeat this with a same equation to start off, but a different set of questions, so we'll approach it from a slightly different angle. Okay, see you next time.